O Jorge já tem a claque, portanto já estamos mais que preparados para o receber. O Jorge Silva vem da Blip, é uma das empresas responsáveis pelo Porto TechHub. O Jorge acompanhou o crescimento da Blip quando eram apenas 25 colaboradores e foi um dos testemunhos desse crescimento. Atualmente a empresa tem 250 pessoas. E hoje o Jorge vem falar um bocadinho do universo Blip, de algumas dimensões técnicas e também da gestão de pessoas. Muito obrigada.
Yep. Hello, everyone. This talk will be in English as well, for the same reasons as Pedro's talk was. So I was kindly invited to be here talking to you guys about the experience Blip had the last 2 years in terms of channel development. Channels are the name that we give to our front-end applications, the one that consume the data, shape it, and display it to the user, okay? So, roughly 2 years ago, we detected that it would be nice to change our web apps. Not because of necessity, because a blind spot, okay. So, our applications worked, they still do. We haven't migrated every single one of them. But the customers were rapidly demanding for speed. Speed not in terms of page rendering speed, but interaction speed. So they wanted to click a button and have a response sub-millisecond, okay? We didn't have that. We had like really fast sites, really fast platforms, but they were not very fast in terms of experience, user experience. So this is a tale about code, people, and infrastructure, and hopefully it will resonate with you. So what we had back then, we had stateless, or kind of stateless, monolithic code bases with highly coupled pieces of functionality. So every model and every module and every service would live on the same RPM, on the same distributable, on the same jar. As we started to grow, we had like huge code bases. Once you change something there, it braked elsewhere. And it was really hard to cope with that. You really had to know how every single piece of code interacted with each other, because you were developing with 150 people, now 250. It's really, really hard to cope with a lot of hands writing code in the same place. And because our web applications, as most certainly yours, is just a function of shaping the data and creating views on top of that, we were just building functions. Functions that add input and produces an output to show things to the user, to build views. So growing the app meant more code, harder to maintain with time, okay? So we had the bespoke framework that worked pretty good for us. It was really fast. It did everything we wanted functionally. It measured everything non-functionally. But being bespoke brings other kind of responsibility. We had to nurture it, which we didn't. So the only thing that made you good at it was time. So the longer you were exposed to it, made you better, not the other way around, where you have merit in being good technically. And it was often the case where people didn't know or haven't the time to build it the right way, because there was no example. So how do I do that? It works. So that was the motto there. So it evolved more on the product dimension than on the technological one. So it did everything that the product owner wanted. But, well, it left the developer unhappy because he had to put a nail a lot of times in a lot of different places in the code, and that hurts with time. So on the people dimension, we had something interesting, which were silos. People often would silo themselves. And the boundary was the programming language. So you do JavaScript, I do Java, we will meet at the end, okay? It will work, trust me. So we were having like functional dependencies on people's work. The front-end developer only could start working once the API interface was done by the Java guy. That is not so cool because it left people playing a lot. So I was one of them, so it was cool. But up to a certain point, just, okay? So in terms of pipeline, so you have like a huge piece of code, right? So it was highly complex, including the tests, mocking, and doing integration tests was really hard, really, really hard, because you had to think about a lot of different functionality that was built by 150 people, 300 hands, so you had to take account for that. So more often than not, the pipeline would break. So we call it gas. So yeah, just kick the build, it will pass that way. And often it did, but it was not magical, right? So it was not voodoo. So everyone started being sad, and it was not a fun place to work anymore, right? We want to produce code that works. So at the same time, again, customers were demanding, I want fast UIs, right? So broken pipeline, fast UIs, not going to happen. Then, the last dimension, infrastructure, right? As Pedro said, infrastructure is kind of something that we sometimes take for granted. Well, as a developer, and you guys as developers need to take account for that, right? The code you write will impact every other function that the other developer writes. So you are occupying a time-shared computing resource. So you need to be friendly to your next fellow developer. So because we had pieces of functionality that were highly coupled together, changing in one place could mean breaking the other, that wrecking ship phenomena. So people had, you started observing fear of changing. So what would happen if I change this? I don't want to be responsible for a downtime. So this still happens today. So something that couldn't be done in a staging environment, it is possible, and we find it out 2 years later just because we are starting to get better at that bespoke framework, right? So that happens when you do not have tender loving care for your code. Again, because you are, for each build, testing every piece of functionality, the pipeline would take eons, oftentimes more than 1 hour, and gas may occur at the last second, right? So you need to re-kick the build, and if you made the commit at, let's say, you're responsible at a Thursday at noon, you would only get to it at 1 o'clock or 2 o'clock. It depends when it failed, when the voodoo happened. One important thing is the way that we used our computing resources was thread-oriented. It means that we had to have like a good enough computing resource to use. So we had to have a good production environment to nurture the high computing resources of building a page for each request, right? So can we do it better? That's the question someone asked 2 years ago. We thought we could. So we started understanding what the market had to offer in terms of tools and ideas that we could build upon. So we started by trying to understand what our problems were. So we had web apps where views, business logic, and data interoperate to build an experience for the user. The data sometimes needs to come from a web pipe, like for a TCP connection or a WebSocket. So we had an I/O bound, a set of I/O bound operations. So that was our problem, I/O, not computing. We were not a compute-intensive product. We understood that the web app, and we all do, this is how web apps work, is just a collection of specialized views on top of data, and that data comes from services or a service layer, which simply cannot be plastic enough to accommodate all the new views that we want to build from here on. We want to grow our product, and having like a language in our service layer that fits and is able to serve everything for everyone is just not possible, right? So that implied collating data from several different services in order to provide the product language, like the product interface, the interface that the views would consume. So we had to have data collation, and it should be fast enough, and it should be easy enough to implement. It shouldn't block us. So we could do it twofold, near or nearer to the client, let's say it in the browser, or in the server side. There are pros and cons to each. So data locality is something that is pivotal to speed, right? There are a lot of talks about it, so I won't dwell into it. But we wanted to have the data the nearest possible to the client, so the experience would be faster. We don't want to wait 2 seconds since we click on a button for the action to appear. So the pros are that data locality. The cons are that our platform is a browser, so it's a very, very complicated sandbox to work with, and there are network limits. So, okay, we need an aggregation layer, something that is product-oriented but developer-friendly at the same time, while respecting non-functional requirements. And we wanted to measure everything. Measurements and metrics are the thing that allows us to understand how we're coping with load with users. How are users using our site? That kind of questions that are pertinent and drive our next features, right? We also wanted to do kinky stuff because we are like a financial product. That's what we do in Blip. And financial products are time series oriented by its nature. So it's price variations and fluctuations over time. So we wanted to stream things to the client. Let's be more efficient. Let's not poll everything. Polling is cool up to a certain point where you can't scale anymore, or it gets very hard or expensive or slow to scale up, that means. So we wanted to send state to the user in a reactive manner. Reactive is just a buzzword, so it sounded cool. The requirements should fit in our aggregation layer. So let's build it. Let's build something that can accommodate for all this non-functional stuff. And most important of all, we wanted our engineers to focus on the value, not on the non-functional part of stuff. Some things just need to happen for granted, right? It's not fast enough, let me put it that way, to have to think about all of this stuff over and over and over again just because I want a new button on the site, right? So we ended up designing something like this, where we have our web app, the exact same thing, but we added an aggregation layer, which is capable of doing polling and pushing. And I missed an arrow there, so this communicates with that as well. But if the interface, the service interface, is able to provide the data that the application needs at a certain time, why not go there directly? Well, let's not reinvent the wheel. So there it is. That is what we ended up with. So let's try to sum it up to this point, what we have and what we want to do. So we have products that work. So building something new over something that is working is kind of strange, so it's crazy. But that's what we wanted because we were feeling strangled on top or with our technology at the time. So we wanted to take it to the next level, better, faster products. Most importantly, at least for me and the guys that helped, was keeping everyone engaged, which is a really hard task. We wanted our engineers to play with the latest technologies and, well, keeping product owners happy. And customers as well, right? So So we want to continue having products that work while we change stacks, both on the client and on the server. So let's go. It should be fun. So I remember 2 years ago, I was recovering from a surgery, and I was home, and the guys tell me, okay, so we wanted to do this, do it, or at least come with ideas. So it was nightmares all the way. At least I was alone. It's not very good. So the client, so speed again. What we had was a superset on top of YY, acting as a framework or as a template, with a huge user land on top of that. Our code base back then was 60% JavaScript, 40% Java, and the rest configuration, templating, and stuff. Changing that 60% of code had to be complex, really, really hard. A lot of hands that wrote that code and heads had left the company. So there were things that no one knew how it worked. So keep it that way. Remember, fear of changing. Ooh. So let's gather a state of the art. Let's see what the market has. And client-side rendering popped up. So it made perfect sense to us. So we were spending a lot of time doing network round trips. And most of the data on the payload, on the response payload, was markup. So why not bundling the client side or the view in the client and just transfer data? That kind of resonated with us. It was cool. So there we have it. So we polled our developers. So guys, this is what we want. We know that we want to do things this way because that's how our customers use our site. They want speed. They don't want sub-second page loads. They want sub-millisecond page interactions. That's what we want. So they played a lot. They spiked with different technologies. And Angular, which is just an implementation detail, you can replace that with whatever, was the result, was the framework that we wanted to use. We knew that we wanted common language, and we wanted to give the engineers the ability to, if they wanted, invest time at home or personal time learning stuff. If they could buy a book and become better, why not? It's all about quick wins, right? So we built it iteratively. So for each product, page-by-page changes, one product at a time. That's where we tried to do single modules inside our existing products. It kind of worked. The experience is not so good. So this was what we ended up doing. For the server, for the aggregation layer. So it had to be fast enough and simple. Fast enough means it must handle our load, and it should scale horizontally, right? Stateless by design. It needs to be easy to develop for. It should not be a framework, but a template instead. So we don't want to force developers to learn yet another new language to develop upon, but giving the developer the ability, again, to study by themselves known technologies would be a major win. So we sit on top of proven technologies. So it was an opinionated set of technologies to form a template. And it should abstract the engineer from the non-functional requirements. Again, metrics, logging, that kind of stuff. Ideally, it should cover all our functional use cases. At the beginning, it didn't. So we are keeping, at this day, evolving it to accommodate for everything. Again, we involved everyone that wanted. So let's join the development force and try to understand what our problem was. It was just a spike. We presented the problem and said, well, we will have a meeting like in 3 days' time where you will be able to present your solution to the wider forum, and let's discuss. Let's see how it seems to the other developer. If you develop in language A, language B, whatever, no limits were put there. So we evaluated everything against the previously agreed weighted list of requirements, and the winner was Node, mainly because this is I/O bound. Okay, the rest is history. So you can replace Node again. It's just an implementation detail. There are a lot of cool technologies nowadays to do the same thing. So we had to build it. So we ended up gathering a set of 6 engineers, which worked pretty half time because the products had to evolve at the same time, and formed like a virtual team. It took 3 months for us to build a new bespoke aggregation tool, which would sit on top of documented libraries. So we didn't have quite to have a nice documentation framework on top of that. It should be simple. So we ended up building something that is pretty similar to Amazon Lambda today. So I was really happy to learn about it a few months back, and it is exactly the same. So 3 months, 2 months to learn JavaScript, because we were server developers. We actually didn't know or knew how to write JavaScript. So a lot of that time was to overcome religion and stuff, because, and that process occurred exactly at the same time. So you had 2 different projects, 2 different timelines. This bespoke framework for the server and this new product. And they had to communicate. So we started at the same time. That product was Exchange mobile site at the time, which was built by very dedicated teams, which, in my opinion, ended up doing the heavy lifting for this new stack change, and they did it pretty nicely. It was actually smooth. Everyone knew what they wanted, so the product was kind of well-defined. The server was, well, not so well-defined, but we knew what we had to offer. So we gathered the 2 teams and defined an interface. So this is how you will call an API that is serving this data for you. This is how you will write stuff. No? Yeah. So it kind of went from there. So this is how you write. They wrote it. It worked. And when the pieces had to glue together, it's almost like that image of a bridge, and they pieced like this, okay? They were not perfectly aligned, but it was kind of neat. And what failed almost every time was the server side, which we had to patch really quickly. So 3 months from 0 to hero. So new stack, keeping the products that we had running, and going to production with it. And, well, we didn't have like performance metrics there, so it was kind of voodoo for us, but it worked. So we are still evolving it as of today. It's now more non-functional work. We need to take better handling of the resources we have at our disposal. We are still improving the way that we do deployments. We want to be elastic all the way. That poses some challenges, but it is happening. And at the same time, the company is changing everything. So do you remember Stream? So you can stream stuff to the client, but you need to stream it right from the data source. Otherwise, it's not efficient. You will put a heavy stress on all your data stores and all your infrastructure. The network will probably not cope with the load. So we are changing all of that. And it's, for me, a very good challenges. And because they are not trivial, that's what makes them interesting. So the possibilities are endless. It is really just the beginning of something new, something that 250 people are now dealing with. It has its challenges. We can talk it on another talk. But thank you. Questions if you guys have any.